Hello, today I'm going to go over graphing sea surface temperature during glacial and interglacial periods. So what we're looking at is approximately the last 400,000 years of Earth's history. So as far as how old the Earth is, which is billions of years, right? This is kind of a small period, but during the last 400,000 years, we've gone into and out of periods of glaciation. So at the highest levels of glaciation, glaciers completely covered Canada and then came down into the United States, forming permanent glaciers throughout this whole area. And then in between glaciers, the interglacial, there were times of warming. And a lot of these glaciers retreated much further up into the Arctic. What we're going to do is we've got some data down here that we're going to graph, and we're looking at sea surface temperature, specifically equatorial. So those are the hottest sea surface temperatures from the past 350,000 years. Now, we have this data. Remember, every piece of data is taken from some sort of evidence. And then when you put all that data together and all the different types of evidence together, when it matches, it gives you some idea of what was actually happening. The surface temperature we get because of these little microfossils. They're little marine microfossils. And we can look at the magnesium to calcium ratio within these microfossils. And that tells us what temperature the sea was when they grew, because it changes. That ratio of magnesium to calcium changes depending on the ocean temperature. So we look back at these fossils and can get a lot of information. And then we also know the glacial periods based on oxygen isotopes. So these are oxygen isotopes that are trapped in the air, trapped in ice cores. And they tell us when we had periods of glaciation and when we had periods between the glaciation. So let's get started on this. I have my two data tables here that we're going to graph. And I got my graph here. And let's start off with our y-axis. We're going to put sea surface temperatures. So, and I'm actually going to add equatorial, because I want you to remember, equatorial sea surface temps, and this is in Celsius. So we try and use Celsius when we're talking about science. And those go from surface temperature 23 degrees Celsius, 24 degrees, 25, 26, 27, 28, 29, all the way up to 30. And then down here is years ago. So we're going to start in the past. We'll start at 350,000 years ago. So I'm going to write years ago in thousands. And for this first line is going to be my 350. So 350, and then we see that every piece of data after that is 25,000 years closer to the present. So 350, 325, 300, 370, 275, 250, and if you go all the way to the end, it'll end with 25,000 and 0. So when we graph this, we're not putting in the glacial periods and interglacial periods, but what we'll see is the graph is going to go up and down. And as we would expect, when surface temperatures are at their highest, the oxygen isotopes tell us that was not a glacial period. And when surface temperatures are at their lowest, that was a glacial period. But you'll notice that the differences in temperature don't change much, anywhere from 1 degree Celsius to 3 degrees Celsius. And that's what we really want to see, is that the difference between a frozen Earth and a non-frozen Earth could be as low as a couple of degrees Celsius. Something to think about as we're going through climate change. So let's graph a couple of these points. 350,000 years ago, sea surface temperature 25 degrees, so I'm going to put a dot right there. 325,000 years ago, 27 degrees, so I'm going to put a dot right here. And you're just going to keep doing that for all of these all the way across, and it's going to show you how temperatures, in this particular case, temperature of the ocean, has slowly changed over time, but matches periods of glaciation and non-glaciation. All right, hope this helps. Thanks.